Hi and welcome to DCO. My name is David Copete. In today's tutorial, you'll see a design for a 3D printed house. Now we start with the base geometry, then create the outside walls, and then the infill. Now the interesting thing about this is you can change all of those inputs to create different iterations of your design. But what's also useful about a script like this in programming your designs using Grasshopper is you can change the base geometry like this polyline. We can set one curve and we can make sure that it works with any polyline. So we can change all of these inputs and create that same design on any form. So here we were using a polyline. We can also use a circle. So if you want to learn a few more tips and tricks about how to use Grasshopper for various things, a lot of the techniques that you learn in this script are going to be useful for other designs and other things you do in Grasshopper. So hopefully you're excited. I wanted to share also this script on my website. So if you want to download that, you can find that in the links below. Other than that, thank you for the support. Thank you for being here, and let's jump into it. All right, so to start the script, I like to have a scale person, and this is so I can know how big the design is going to be. Now, understand that when I do my scripts here, I have my display as draw icons, draw fancy wires, and draw full names. You may not have that by default. So if you see things different in my script, make sure to adjust that so they match. So now that we have that done, let's start here with construct point. And this is going to give us a parametric point. We can always change the location here, but we can also override it if we do want to change the location. This lets us do that. Now we're going to be creating a grid. This is going to be a square grid. So when you type in square, you'll bring in the square grid here. Now it has 4 inputs. We're going to use the point as a plain input. The size is going to be how big the cells are going to be. So I'll use a slider here. Now the number of your slider is going to depend on your units. So you might have a different size for that. Now let's change the extents. So I'll go here to a new slider. I'll go to 4 and then 4 this way. We can always change that as well. Okay. So now that we have this as 4 by 4, this is going to help us create the base geometry. What we need to do now is understand how this is organized, because we're going to be removing some of these cells to create the base geometry. And so I want to show you that technique here, which is bring in an area component. Now, once we have this area component, then we can bring in a point list, which will let us know how this is organized. Now, the size of it might be too small, so let's change that. And notice that this is a grafted set where this is 0, this is 1. So these are different groups of them organized this way. If we flatten the input, you'll see that now we have 0, 1, 2, 3, and now this is just one list and it's organized this way. So what we want to do is be able to remove some of these. So for that, I'll use call index. And this will let us use those cells as the input. And by knowing which ones we want to remove, we can create the base geometry. So let's remove 0, 1, 4, and 5. And so we can right click here, set multiple, or you can bring in a panel, which I use by using quotation marks. Make sure you right click, go to multi-line data, And now here we're going to go 0, 1, 4, and 5. Now we can plug those into the index, and notice that it removes those. So we can always go in and let's say remove another one if we wanted to. But now that we have this, let's use these as the ones that we'll use for the base geometry. Now we need to bring in and put those together using region union. So region union will let us pick all those polylines that are separate and give us a perimeter that will allow us to use that as the geometry. So now we can hide the initial portion, and we can also hide the point list. So the idea here is going to be to create the 3D printed form of a house. So it's going to require to have the outside perimeter, the inside perimeter, and the infill of how the house will be printed. So we'll take this, and first we'll round the edges. So we'll do fillet edge. This is also because when you print something, and I'm familiar with 3D printing, so it's a similar process, just in a larger scale. When you have rounded edges, you can have a continuous path and not necessarily have it jog here to another direction, and because that causes some issues when you're printing. So here we're going to use the radius. We'll just say 60. We can even go past that. So let's make this a max of 240. And at some point there's a limit to that. So let's just go here to 120. Now I'll hide the region union. And now we can focus on this one to create the base form for the walls. So what we'll do is take this and offset it. So we'll bring in an offset curve component. Then we'll offset it in, it's going to offset to the outside by default. So we'll go here to a negative component and use the size that we want for the depth of the wall. Now that we have this part, we need to offset this towards the inside to create the inside part of the wall. In this one, offset it to the inside. Now, when you 3D print something though, you don't need to give it a thickness. You just need the path, because the 3D printer is going to follow that path and then do the printing right on that path. So what I'm showing here is more than anything to create the idea of what you would see when it's done 3D printing. But in reality, you'd probably just use two separate paths like this, and depending on how wide the 3D printer prints the concrete, then that's going to, we can show that here. So we're just going to visibly show it here. So we'll go to offset this again, but this time not to the outside. We're just going to say, let's say it prints 3 inches or 1.5 inch thick. So that's going to be where the concrete runs. Then we'll do the same thing for the other side, but the other side is going to be in the negative direction. So then we'll plug this in to that outside one, and then use a negative component to offset it to the inside. So now with these two, we can create a surface. So we'll go to boundary surfaces between this one and this one. Notice it looks at them as separate. So we'll graft tree for the one before. This will let it work together as one. So now we create that surface in between. And same thing with the one below it here, which is going to be this as the grafted tree, and then this one as the offset. So we'll override these two. Now, for the inside portion, there are different ways that we can design this. Now, typically, when you 3D print it at a smaller scale, but even when you 3D print at a larger scale, you're going to have some kind of infill or some kind of way for the structure to connect the inside and the outside to create rigidity, but also to fill in some of the gaps that would typically be in a house, let's say made out of wood, would be the wood studs. So now for that, we need to take the two separate ones here, and we're going to now create a offset on the inside here. Now the next part is picking out one of these two that were offset to the inside. We're going to pick the outside one. Now we're going to subdivide it to create the spacing. So this is going to be using horizontal frames. Now this is going to ask for a count. So let's say we want to have 100. But here's the thing. If we want to do the exact spacing in between them, or know the minimum spacing in between, then what we need to do is get the length of this. So we'll take the length of that curve divided by the spacing that we want in between. So let's say 24. What this will do is give us how many we're going to need and what the spacing needs to be in between. So if we want them to be 24, so it's the length divided by the minimum spacing, and this will tell us and give us how many we're going to need. So we need 146 subdivisions for them to be 24 inches apart, depending on the length. And this will let us be consistent, not just for this script, but if we want to add on to the script, then the length is always going to be the same because it's divided by the minimum size. And then that's always going to change the number of how many we need. So with this now, notice that we have these construction planes that will let us move that point. So now we have these frames, we're going to move them perpendicular or using these construction planes and move them in. Here would be the Y direction. So what we'll do is we'll take these frames and deconstruct the plane. Now we can use this origin as the points. And now we need to pick every other point to move that to the other spot. So we need to pick every other one, and the way to do that is this way. We're going to take these points, we're going to go to list item, we're going to plug in all these points into it. Now the index is going to be every other one. So what we need to do is now understand how many points we have. So we'll go to list length. We have 147. Okay. So now what we need to do is create a series of numbers that step by 2, which means every other one. The count is going to be 147 divided by 2 because we only need half of them. And so now we plug that into the index, and notice that we're picking now every other one, which means that we need to do that, take these and move them in the Y direction relative to each frame. So what we will do is take this, but we can't plug in the y-axis because we need to pick every other one of these frames. So what we need to do is also copy this and do that same thing to the y-axis here. So now that we have only picked every other y-axis, we can use the amplitude component, use this vector. The amplitude is going to be how far this is, and be able to move these points in that direction. So notice when we plug this in, it's only going to move it a little bit. Now we need to calculate what that size is, which is the overall offset of the wall minus and subtracting the first part 1.5 and the second part 1.5. So we'll go here. We'll go to the offset 16. So we'll do 16 minus 1.5 times 2. Because we're doing 1.5 here and 1.5 here. And so we need to have that space in between. So I'll bring it over here and notice that it starts getting messy. So what I like to do is just hide the input. Wire display hidden. Now we can use that result as the amplitude. And it moves it exactly there, and it's tied to the wall here. So what we have to do now is replace from these points. We need to take these points and replace them with those points. The way to do this is, and I've shown this before using creating the landing, but it's insert items. Actually, no, it's replace items. Okay, so now that we have this, what are the items that we need to replace and where are they located? So these are the points and the items we want to replace. The points are going to be, or the index is going to be these, and the list is going to be these points. So notice that now what it does is it takes those points and it replaces them with, it takes these points and it replaces them with those. So now we can hide everything except for this one. And we've successfully offset them. Now we can put them together using interpolate curve. So what's cool about this is we can change the spacing if we want more or less spacing in between. This can also be useful if you're into 3D printing. You can also use this as an infill for your designs if you don't want to create the infill when you're slicing your object. Now we're going to take this, which here's the thing. At some where it starts and where it ends, there's going to be a gap. Let's see if we can find it here. And that's because here it's not closing it. So we can either right click here, set Boolean to true, or we can do a Boolean toggle. And then double click here and make it true. Let's see if we can right click here, set Boolean to true. Let's change the spacing here because it's kind of causing an issue there. Okay. The reason for that is because sometimes, so let's see here, 12. Sometimes the last point, so this is why, this is one of the things I want to do, is the spacing in between for the count can change. And so I like to use an absolute here, which makes sure that it rounds this. Let's see here. Or rounding it to the nearest whole number. This makes sure that this will work. So let's change this back to 24. Oh no, what happens is it has to be an even number for this to work. Why? Because if you have an odd number, then it's going to end up and not down. So sometimes you're going to have an odd number, which is 47. And so that is something just to keep in mind, is that if the number is an even number, then it'll work. Otherwise, there's going to be an offset that's wrong there. Okay. So now with that, let's turn this periodic to true. And then we can always turn it off if we don't want that to be closed. I'm showing you here some of the intricacies of creating a script, and there's always something to fix. All right, so now that we have this, we're going to be doing the exact same thing that we did for the walls, but what happens is it's not going to be 1.5 inches just to one side. It'll be an offset. So we'll take this 1.5 divided by 2, and we'll bring this over to the other side. So I'll hide the input, and then this input is going to get an override with the interpolated curve. And since we're going to one side, then we'll do the same thing to the other side, which means that this will be positive, and on this one we'll do negative. And so that's why we divided it by 2, because we want it to be the same to each side. We want this to be the center line, and we'll create the boundary surface between the two. So what this script does is it can take any curve or any closed polyline. So we'll call this curve. And it can turn it into a 3D printable form that has the outside, it has the infill, and we can always go back here and change the design that we want. So let's say we look at this and we go, you know what? I want to add 0 and 4 and create a little courtyard here. So let's go here to remove 0 and remove 4. And notice that now that has been incorporated. The only thing is this part of the infill, like we said here, that's going to have an odd number. So if it has an odd number, we'll do this. If it has an odd number, we'll do plus, and then we'll make a point list of 0, a value list. We'll go inside of the value list and we'll call this one 0. So if we add by 0, it's the same number. And if we add by 1, so then we'll do zero and then 1. So the input is going to show 0, and then it's going to be 0. And then the input is going to look like 1, and then it's going to give 1. And this is going to be infill spacing, or infill fix. So if we want to fix the infill, we'll do the nearest number, which is 199 plus 0, stays the same. And if we do plus 1, it'll fix it. So it just depends on whether you see that issue. Then you come in here and using just this value list, we can change it and fix that issue. The other cool thing about this is we can remove more portions if we want to, but if we have a different form, let's say like this, we can set this curve. So let's give that a shot. And it's also going to work, and it's going to round off the edges. So what this does is it creates it can generate as many forms as you want with whatever curve input as you want. I was just showing you here at the beginning a technique where you can take a grid, remove some portions, and that way you know, let's say, the size of the space inside. But if you have a specific polyline or a specific line segment, we can even use this with the circle. Now the radius or the fillet is not going to work, but let's try this one out. So let's set one curve. Yeah, this will work with the circle as well, and we can even deform it here if we want to, and it'll still work. So I'm showing you here with these exercises and with these different tutorials is once you create a script and you have things designed correctly, it's going to be very useful because you can use it over and over again with different forms. You can change the thickness of the walls. Now, if you see things here that are not too accurate, you can always account for those things or change the quality to high, and that will make it look a lot better within the script. So if you want to download this, I'll have it available on my website. I'll have more tutorials coming up with different things. So make sure to subscribe. Also, let me know what ideas you'd like to see. Those are things that I like to add to my list, and if I can get to them, I can. Otherwise, thank you very much for being here. I'm going to be showing you a work session where I developed a few different ideas using the same concept. So stay tuned if you want to learn a few more techniques in the work session. But I appreciate the support, and I hope to see you in the next video. So at the end here, one of the things that I did was I took those surfaces that we created for the infill and for the wall depth, and I extruded them here using an extrude component and using a Z vector and an extrusion slider. So I wanted to include that to make sure that you guys, so I finalized the tutorial, and then I also added two custom previews here, so you can see that this is going to be for the infill and this is going to be for the outside.
generate, iterate.